Welcome to another lesson for this week for the Unit 2 test preparation. This one is trying to distinguish, these questions where, when do I use this formula 2 to the n minus 1? And when do I use the formula, a plus 1, b plus 1, c plus 1, dot, 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 z plus 1, minus 1. So when do I, when do I use this formula on the left with the 2n minus 1, and when do I use this sort of other formula with the other 1? So let's start with a simpler question. We're going to look at this del E question. So at a del E it says there are n number of toppings to put on your sandwich. How many different sandwiches are possible? Okay, let's begin with an easy case. Let's start with the case n equals to 3. So let's say our toppings are pickles, onions, and lettuce, just as 3 possibilities. Now, let's go through and see what kind of sandwiches we can make. We're going to have to analyze the cases. So the first case is 1 topping. And obviously there are 3 ways to do this. There could be P or O or L. 2 toppings, there's a little bit more to do here. There's P or O, P and L, and then O and L. 3 toppings, there's only one way to do that. You get all 3 of them, POL. Now, sometimes the 0 toppings case, and obviously there's only one way to do that, would be a plain, sort of plain sandwich. Wouldn't have any toppings on it. Sometimes you need to count that one, and sometimes you don't. So I believe on the test it says, the pizza or sandwich or whatever has to at least have 1. So obviously if it at least has 1, it's only going to be these cases, right? 1 or 2 or 3. Now how many things do we count here? Really, for 1 topping, what we're actually seeing there, I mean I listed them, right? P and O and L, but what you're actually seeing there is 3 toppings. Oops, 3 toppings, choose 1, right? And that's how we ended up with P, O, and L, which was 3. Then we did, on the next line, we did 3, choose 2. Just quickly do that. So 2, 3, choose 2. And again, that was equal to 3. So there's 3 ways to take 1 topping. There's 3 ways to take 2 toppings. There is only 1 way to choose all 3 at a time. So, and of course that corresponds to 3, choose 3, which is equal to just 1. The 0 case would correspond to 3, choose 0. And of course there's 1 way to do 3, choose 0. Now, so let's just put that one there just so we have it. So we're just going to go 3, choose 0. And this is of course equal to 1, because anything choose 0 is always equal to 1. Now, these cases, if you think about it, I wanted to basically add up all the cases. So there are 7 cases of at least 1, and then there is 1 case for 0. So grand total, we have 8 ways to make a sandwich, provided the plain one is allowed. This 8 corresponds to the row of Pascal's triangle, as you can see here, right? 1, 3, 3, 1. That is the 3rd row, because remember Pascal's triangle starts at the 0th row, but this is the 3rd row of Pascal's triangle, 1, 3, 3, 1. We know that the sum of any row of Pascal's triangle is equal to is equal to 2 to the power of n. And this is the real idea for how we are going to solve these questions. We're going to basically, instead of doing what I did here, where I listed them all and added them all up, I'm going to use this formula because any row of Pascal's triangle makes 2 to the power of n. So let's go ahead now and we'll look at the same thing, but let's look at n equals 12. So this time there are toppings, A, B, C, etc., etc., up to 12. Now, the cases here would be, 1 topping, 2, 3, and so on. But you're going to find that choosing among 12 objects, that if we try to just list them out like this, we're going to be here all afternoon, right? So we don't want to be doing it that way. What we want to do here is use the Pascal's triangle method. So if we can make the number of choices, any number, right? We could choose 1, we could choose 2, we could choose 3, we could choose 4, all the way up to 12. Well, I know that the sum here, right? But the sum of, just quickly, let's go, just make this quick. So binomial, 12 choose 0 plus 12 choose 1 plus 12 choose 2 all the way up to 12 choose 12 is equal to 2 to the power of 12. And we're going to use this fact now. Oops, sorry, didn't quite post correctly. 2 to the power of 12. Okay, so we're going to use this fact now to basically skip all the work I did with 3 toppings, because again, it's not feasible to do that with a higher number like 12. And we're now going to say that you can make 2 to the 12 pizzas, or sandwiches, I should say. And if we're not allowed to have the 0 topping sandwich, then I have to subtract that 1 away. Okay, and the idea with that is, sometimes the question will say it has to have at least 1. So again, we could add up 12 choose 1 plus 12 choose 2 plus 12 choose 3 all the way up to 12. Or we can use the fact that I know that the whole row adds up to 2 to the 12. And then I can just take away the 12 choose 0 part, right? Really, this part is binomial 12 choose 0. And that is where that sort of 1 comes from, right? Which is equal to, this is where we get the idea of 2 to the 12. 2 to the 12, take away 1. Okay, so in this case, if there are 12 toppings on the pizza, we're just going to go 2 to the power of 12. That's 4,096. So we know there are 4,095 sandwiches possible with at least 1 topping. Okay, and that's how you solve these ones, and that's how we recognize that it's a sort of 2 to the n question. If you want to imagine this using sort of the lines method, maybe we can sort of think about this for a second. Let's go back to, this kind of method, and so on and so on. Now, if you think about it, the first option for toppings is either we have A or not A, right? Either you have, let's say, cheese or you don't have cheese. How many options is that? That is 2 different options, right? Whether to take this topping or whether not to take it. Now, topping B is the exact same thing, right? You can either take it or not take it. So there's 2 choices. Again, you can see what I'm getting at here, right? Is that for as many toppings as we have 1 choice whether to take it or not, right? And so you can see that this is going to be 2 times 2 times 2, all the way as many times as we need to get up to our maximum number of toppings. And then we still have to subtract 1 at the end because we're not allowed to pick not this topping for all 12 boxes, right? At least if it says, at least 1 topping needs to be chosen. So this here is what's going to help me lead into the next part of this question, okay, which is, what do we do when the elements are not distinct? So in this question, there are 12 toppings, and they're all obviously distinct from each other. So, cheese is not the same as lettuce, is not the same as pickles or onions, and so on and so on. So they're all kind of their own thing, okay? We're going to look at another kind of question here now, where we're looking at some objects that are identical. So let's change gear a little bit here, and we'll move over to one of these questions where we're looking at, sums of money, or it's identical objects where the number of slots in the question are not clear. So think about this as different from, a word arranging question. How do I know that this is a different kind of question than a word arranging question? In a word arranging question, you have 10 letters that need to go into 10 spots. Here, okay, I have 16 green chips, I have 13 red chips, and I have 2 black chips. But how many slots are they supposed to go into? You know, a sum of money could be made with only one of these things. It could be made with 3 of them. It could be made with 7 of them. It could be made with 8 of them or whatever, right? So if you try to go about it doing this way, or you try to make slots for yourself, the problem with doing it like this is you don't really know uh, how many you're going to be using, right? I mean, are we going to be using 6? Are we going to be using 2? Are we going to be using 8? I mean, really what you would have to do if you wanted to do it that way is you would have to uh, check every single case, right? So I'm using 1 chip. Well, how many ways are there to use 1 chip? All the way up to how many ways are there to use, 31 different chips, because that's how many chips I have total here, right? I'll just put that here to the side. 31 chips in total. Now, this question, what we're going to do is we're going to treat this a lot like the way we were thinking about that sandwich question at the end. Instead of thinking about it as how many I'm going to choose, I'm going to think about it as maximum number of green plus 1 times max number of blue, or red, I'm sorry, plus 1 times max number of black plus 1. Okay, and this is, why are we going to be doing this? Okay, and again, minus 1. If you think about before, with the sandwich, right? When we wanted to say cheese or no cheese, that's 2 options, yes or no. So in all the boxes, we put a 2. In this kind of question, we could have 0 greens, 1, 2, 3, 4, all the way up to 16. So the numbers from 1 to 16 are the number of green. So again, we would, in this question, my answer would be 17 times 14 times 3, take away 1. Okay, and this is coming from the fact that the maximum number of greens is 16. So I could have 1 or 2 or 3 or 4 all the way up to 16. I could also have 0. So that's why I have plus 1. The number of reds, there's 13 red chips. So I say 13 plus 1, because I could have 0 chips for red. The number of choices for black chips, I could have 0, 1, or 2. That's 3 choices. Now I take away 1 at the end, because obviously if I have no chips, no green, no red, no black, that's not a sum of money, right? It's just an absence of anything. So that is not considered to count. So how do you tell the difference between sort of this like pizza toppings versus, sums of money question? In the pizza toppings, each topping was unique. In the sums of money, you have multiple items of the same value. And that's the difference between these two things, right? That if I go with, 3 green chips, that no matter what 3 green chips I choose, it's always the same amount, okay? So this is hopefully going to help with how do you distinguish between these two. Remember, always try and think about it as the choices that you have. You could choose, all the way up to 16 different green chips, right? So you have 17 choices there. 0, 1, 2, 3, 4, 5, etc., up to 16. So I'll leave a couple questions on the bottom here again for you to try, and hopefully this helped you with 2 to the n and a plus 1, b plus 1, c plus 1 style of questions.